Hi everybody, welcome to Test 2 review in Calculus 2. As always, we have the topics on the top and the formulas on that side. So let's start. First we have trigonometric integrals. The integral involved on the trig function that could raise to a power. So first we have the power of sine, cosine. Here what we have. So if we have the power of sine is odd, then u equal to cosine. The power of cosine is odd, then u equal to sine. So always the order function. Right. So first here we have sine cube of 7x. So we know u is going to be cosine of 7x. So I will start with that. Let u equal to cosine of 7x. We don't even have cosine of 7x, but that's alright. We're going to take derivative. Du equal to cosine is going to be negative sine, and then the 7x derivative of that is going to be 7. So we use the chain rule, and we have negative 7 sine of 7x dx. We can say du over dx, and then we multiply the dx to that side. Right. So to get du, we have to have a sine of 7x dx. Here we have a sine of 7x, so that's good. So the first thing we'll do, let's just put that a line here. When we have that integral, is to write the sine cube as a sine square, and then times a sine of 7x then dx. We have the sine of 7x dx, so let's just divide by negative 7 on both sides. So we have du over negative 7 equal to sine of 7x dx. This of course will turn into du over negative 7, but that will come later. And also a sine square here we have to write in terms of cosine, so that we can convert this into u. So we have the Pythagorean theorem that relates the sine and cosine. So we have sine square plus cosine square is 1. So here sine square is 1 minus cosine square. Here we have the sine square will turn into 1 minus cosine square. Again, we'll talk about the limit later. Here we still have 0 to pi over 7. The sine square of 7x is 1 minus cosine square. The angle is 7x. So those two are equivalent. For now, let's just say sine of 7x dx. Now when we change this into u, we have to change the limit to u as well. So u is equal to cosine of 7x. When x equal to 0, u is cosine of 7 times 0. Cosine of 0 is 1. When x equal to pi over 7, u equal to cosine of 7 times pi over 7. 7 and 7 cancel. Cosine of pi is negative 1. Right, now we're ready to do the substitution. The limit, instead of go from 0 to pi over 7 for x, we go from 1 to negative 1. the function cosine square here, that become u square. So we have 1 minus, here's a u square. Sine of 7x dx, that is du over negative 7. Right? So 1, negative 1. Here we have the constant of negative 7 at the bottom. So if we move outside, the integral will be at the bottom. On the top is going to be 1. And then we just have 1 minus u square du. One thing we can do is when we interchange the limit, the integral becomes opposite. So we get rid of that negative sign by switching the limit from negative 1 to 1 instead of 1 to negative 1. And then we still have 1 minus u square du. Alright, now we just integrate 1 minus u square, integral of 1 is u of u square u cubed over 3. That goes from negative 1 to 1. First, if we put in 1, we have 1 minus 1 cubed over 3. That's where we put in 1. And where we put in negative 1, we have 1 over 7. Negative 1 minus negative 1. Cube over 3. Right, 1 minus 1/3 is 2/3 times 7, 1 over 7. So 1 over 7 times 2 over 3. Multiply straight across, it is 2 over 27. I mean 21 when 7 times 3 is 21. Minus. Here we have negative 1 over 7. Negative 1 times negative 1 plus 1/3, so negative 2/3. So we have 1/7 times negative 2/3. 2 over 21. So that plus also 2 over 21, which is 4 over 21. Right, to recap, the power of sine is odd, so u is equal to cosine, and the rest will follow. We have to change the limit. Here's what we can also do is the function is even, the limit is symmetry, so we just go from 0 to 1 and then double the integral. Right, so that is the first one. Right, let's go to the second. Now second problem, we have sine square and cosine cube. Now the power of cosine is odd. That means u is the order function, u equal to cosine. Here the power of sine is odd. It is equal to the order function cosine. Here cosine is odd. U is going to be sine. So that's what we start with. Let u be sine 2x. And also note that it has to be the same angle. If one of them is 2x, the other one is 5x, we cannot do this. Right, u is equal to sine of 2x. We take derivative. Du over dx is the derivative of sine is cosine. And then the chain rule, we have to take derivative of 2x. So that makes a 2 dx. Right. course the dx divided by dx and we move to this side. Just that for now. Now this integral, first we're going to need the cosine of 2x, one of them, so that we can turn to du, right? So the sine square here, that's alright, just gonna keep it a sine square of 2x. The cosine here we have to split into a cosine square and then a cosine of 2x. So cosine square and then a sine. After that dx. Right. So we have sine of 2x dx. I'm sorry, that was cosine, right? Right. I just copy it wrong. So that is cosine. Right. So here we have cosine of 2x without the 2. So I will divide by 2 on both sides to have cosine of 2x dx. Cosine of 2x dx, that is du over 2, which is good. We have in terms of u, sine square here, that is u, so this is u square. All we need to do is rewrite this as the function of u. Luckily we have Pythagorean theorem, Pythagorean identity, so cosine square is 1 minus sine square, so this one is equal to 1 minus sine square of 2x. Right. Now put everything together. That becomes a u square one minus sine square. Again, this sine square, I just write that for now. I'm going to switch the color. And then this we just write du over 2x over 2. I don't know where the x come from, so that's 2. Right, the sine 2x is u, so this is u square. So after all of that, we have u square 1 minus u square du over 2. Right, there's a constant, take that outside, but at the bottom. I will multiply this out of u square minus u to the 4th du, and then we just integrate 1/2 u cubed over 3 minus u to the 5th over 5 plus c. We can just multiply it out. 1 over 6 u cubed minus 1 over 10 u to the 5th power plus c. Right, and that is 1 over 6. U is sine of 2x, so sine cube 2x minus 1 over 10 sine to the fifth of 2x plus c. Right? So that is 2. Next we have the power is even. So that is for power reducing. So if one of them is odd, it is easy. If it is even, then that's just power reducing. So first we will write the sine to the fourth as the sine square, and then we square again. Now the power reducing, let me get there. So power reducing here, the sine square is 1 minus cosine of 2x over 2. So it becomes 1 minus cosine of 2x over 2. Don't forget we still have a square. Right. Now when we square, we will square the top and then we square the bottom. Here the bottom is 2 squared, which is a constant, equal to 4. Take it outside, so that divided by 4 at the bottom. Right. The top, then we don't have the 4 at the denominator anymore. We just have 1 minus cosine to x squared, which is this, multiplied by itself. So 1 times 1 is 1, and we have negative cosine to x, negative cosine to x, so negative 2 cosine of 2x plus cosine square of 2x. Right. Here we still have a cosine square here, which is another power reducing. So 1 over 4, 1 minus 2 cosine of 2x. This is power reducing, so it's going to be plus cosine square. The power will be reduced, but the angle is going to be double, and cosine is going to be cosine of double the angle, 4x over 2. So that's equal to that. So I have 1 over 4, 1 and 1/2. We split this out, 1/2 and then 1/2 cosine of 4x. 1/2 and 1 is the 3/2 minus cosine of 2x, and then plus 1/2 cosine of 4x dx. So that will be 1 over 4 now we just integrate. 1 over 4 3/2 theta minus cosine of 2x, integral cosine is sine, and then we have divided by 2, and then we have 1/2 cosine of 4x is going to be sine of 4x divided by 4, then plus c. We can just leave it like this because that is the integration already. If we want to just multiply it out, that will be 3/8 theta minus 1/8 sine of 2 theta. I don't know why I write theta. It is x, sorry. 2x. And this is 1/8 and 1/4. So 1/32 sine of 4x plus c. So when we have the powers even, we have to use the power reducing. So that is where we have the power of sine and cosine. Right. Next, where we have secant and tangent, power of secant, power of tangent. Right. So the power of secant, the first one, the power of secant is even. So let's go over the rule first. The rule say if the power of secant is even, let u equal to tangent x. So we just know that's going to be u equal to tangent x. With that, du is equal to secant square dx. So we're going to look for secant square. Here we have the secant to the fourth. So let's split that in secant square times secant square. So we're going to have 6 secant square times the secant square, and that is du, which is good. We just need to convert this secant square into a tangent, which is u. By the way, we already did number 4 in class, so we're not going to do that again. Alright, so secant and tangent related by Pythagorean identity. Tangent square plus 1 is secant square. So that is going to be tangent square plus 1. So we have 6. That is what tangent square plus 1. And then let's just write secant square. Right. Now, as mentioned before, that is du, and tangent square, u is equal to tangent, so this is u square, and put everything together, the integral becomes 6 times u square plus 1, and then du. We can take the 6 outside, or we just multiply it, distribute the 6 inside. So I will do that. 6u square plus 6 du. So integrate this should be easy. 6u cubed over 3 plus 6u. Right. Because plus c, so that will be 6 and 3 cancel out, 2u cubed plus 6u equal to 0 plus c, and u is tangent, so 2 tangent cubed plus 6 tangent plus c. Right. So this one is easy. We just have x, the angle is just x, so we take derivative, and that come out right away. On the first one, when we do the substitution, it is not right away, so we have to divide by the number to get. So this is going to be du and something else. It's not just du. This one is just du, so we don't have to do anything else. So that is that. So when we have the power of secant is even, u is equal to tangent. That one's clear. Right. This one we have the power of tangent is even, which is not the first two rules here. Not the first two rules. So if the power of tangent is even and the power of secant is odd, then use Pitágoras identity. Well, this one's either, so I'm going to use Pitágoras identity on that one. Right. Of course, tangent square plus 1 equal to secant square. That is the Pitágoras identity for tangent and secant. But first, the tangent to the fourth, let's just say tangent square times tangent square, or I could say a square like this, but let's just say tangent square. Right. We use the Pitágoras identity about both of them. Or maybe just one of them. Right. The tangent square here is secant square minus 1. And then I still have the tangent square. For this, let's just multiply it out. You have the secant square, tangent square, and then the tangent square. Yeah, multiply it out and split the integral. Right. Now let's focus on this one. This is multiplied, by the way. Now we do have the power of secant is even. So if the power of secant is even, it will be just like this. U equal to tangent. So for this integral, right over here, let u equal to the tangent of 60, because we have the secant square, u equal to tangent. That's directly what we have. Taking derivative, du equal to tangent is going to be secant square. Don't forget we have to multiply by 6, which is derivative of 60, and then we write dt on this side. Originally we have du over dt, and then we move the dt over. Right. So what we see is we have the secant square here and the dt, so which is good. But we don't have the 6, so let's divide the 6 on the other side. I'm going to put the secant next to the dt. So the tangent of 60, the secant square of 60 dt. Right. The tangent square course we can convert to sine and cosine, but we also use the Pythagorean identity on that one. Let's convert that to 1 minus secant square. I did not want to do this from the beginning, from here, because in that case, if we put 1 minus secant square here, when we multiply that, we have the secant to the 4th power, which doesn't help. The secant square is much better. I guess it could help, but yeah, secant to the 4, we know how to do it. But anyway, I don't want to put the secant square here. When we multiply, it is going to be secant to the 4th power. We could do that too. Anyway, secant square here and dt, that is du over 6. And the tangent square here, that is u square. So we have the integral of u square and du over 6. And then minus, let's distribute the integral. So we just have dt minus the negative, that's a plus secant square. The reason we just write the secant square, because that is the integral of tangent. Since derivative of tangent derivative of tangent go to secant square, the secant square go back to tangent when we do the antiderivative. Alright, here we have the 1/6. Let's bring that outside at the bottom. Let's just keep that for now, it doesn't matter. We can do this pretty much in one step. 6t dt. Right. Integral 1 over 6 u cubed over 3 integral of t is just integral of 1 is just t, and then plus secant square is going to be tangent, but it is divided by 6. I make a mistake here, sorry. The tangent square, actually this should be the secant square minus 1. Here since I write that opposite, so that turn it to a plus. Sorry. So that a plus, actually this will be a minus. So that the plus, and that is negative. Sorry, tangent square, secant square minus 1. Since I write 1 minus secant square, I have to negate. Turn that to opposite. All of that is still correct. Sorry about this. Anyway, so multiply out 1 over 18. U is tangent, so tangent cube plus t plus, actually this is minus, so minus 1 over 6 tangent 6t and then plus c. Right, once again, sorry about that. Yeah, so let's just write So again, since we make a mistake there, so let's just go back and turn that to a positive. Turn that, then that will be correct. And then we have positive, negative, positive, negative, and then positive, negative. Right. So that's one. That is that. Next we have secant cube and tangent cube. So if we look at the second one, when the power of tangent is odd, then u is equal to secant. So let's just write that. So we should see that u is equal to secant. So let's start with that. Let u equal to a secant of x. Then derivative is secant tangent dx. Alright. So first, we're going to need to get the secant and a tangent to go with the x to get the u. So the secant cube here, if we split that into the secant square and the secant, and the tangent is equal to a tangent square and a tangent, that should work. So secant cube is the secant square and the secant, a tangent square and the secant and a tangent. So tangent cube is tangent and tangent square and tangent. Now we're going to need to move the secant and the tangent and the dx together. All of that will be du. So I put those two to closer. The secant square and then the tangent square. After that, we have the secant. We have the tangent and the dx on the recipes for the u. Right, so we have the u, which is good. Secant square here, that is going to be u square. The rest, we just need to write tangent square as secant square or secant, because that's going to be u. Right. So that will be, just be careful this time, tangent square plus 1 is the secant square. So tangent square is secant square minus 1. Right. After this we'll have secant square, just rewrite that. Tangent square is secant square minus 1. And then we still have secant tangent. Right. Now everything in terms of u, that is u square du. u square minus 1 du, which is u to the 4th minus u square du will be u to the 5th over 5 minus u cubed over 3 plus c, and u is secant, so secant to the 5th minus secant to the third over 3 plus c. Right, that's what we have. And then what was that? I think 5 to 7. Right. Next integral involve the cosine square minus x square. Right. And for that, I'll just do 8. Right. So let's just go to the trigonometric substitution. So when we have a constant square minus x square, then x is equal to a sine something. So 81 is 9 square. So for this one, the substitution is let x be 9 sine theta. First I will rewrite the problem too. I prefer to write the dx at the end. What's the book? 9 square minus x square. Right. Let's see the substitution. If x equal 9 sine theta, then dx is equal 9 cosine theta d theta. I will not change the limit here. Let's keep the limit for x. At the end, we substitute back in the limit for x. So we go from 0 to 1. 1 square root 9 square. So that is 81 or 9 square, doesn't matter. Minus the x now becomes the cosine 9 times cosine theta square. Dx is x is the sine. X is the sine. Just use because the dx is the 9 cosine theta. 9 cosine theta d theta. Right. Remember, x is 9 sine theta, so that should be 9 sine theta. Right. So we have 1 over square of 81. I will factor out here 81 and 9 square is also 81, so put 81 and then 1 minus sine square and then 9 cosine theta d theta. Right. 9 square is 81, factor out 81, we have 1 minus sine square. Right. Split out this, we will have square of 81 and 1 minus sine square is cosine square. So this turn into a cosine square. And square root of 81, square of cosine square. And we still have 9 cosine theta d theta. Right. So that is just turned into a 9 cosine theta at the bottom. And then 1 and 9 cosine theta d theta. Actually everything turns out, cancel everything. We just have d theta. Yeah, so that just equal to theta. Be careful though, on this one we did not change the limit for x. So here if we write 0 and 1, it could be wrong. It could be x equal to 0 to x equal to 1, because those are the limit for x and not the limit for theta. We did not change the limit at all, so it should be this. Right, now we just need to figure out what is theta. Right, and for that we go back to original problem. This is what we have, x equal to 9 sine theta. So if we want to solve for sine theta, it is going to be x over 9. And if we just want the theta, it's going to be the inverse. So here we just have the inverse of x over 9. Go from 0 to 1. So if we put 1 in, we have that, and we put 0 in. Since sine of 0 equal to 0, inverse of sine of 0 is also 0. So we can use the calculator too, but this is going to be 0, so that is all we get. Sine inverse of 1 over 9. Right, I think I need to do number 9 as well, because that is slightly different than this. Right, even though it looks simple. Right, 36 minus x squared. Right. So the substitution is still the same. 36 is 6 squared. So we're going to let x be equal to 6 cosine theta. In that case, dx is I don't know why. If we let equal to sine, then the derivative, it's just cosine, will be a lot easier. We don't have to deal with the negative sign. Sorry. X equal to 6 sine theta, then dx is 6 cosine theta d theta. Alright, now just put back into the problem. Square, let's just keep 36. X is equal to 6 sine theta, so 6 sine theta for x. Square that. Dx is going to be 6 cosine theta d theta. Alright. 6 squared is 36. We factor out 36, and then 1 minus sine square, and then times 6 cosine theta d theta. Right, 1 minus sine square is cosine square. Right. Square root of 36 is 6. Square of cosine square is just cosine. So we have 6 cosine and 6 cosine. Here we have 6 and 6, that's 36 cosine square. We can write the 36 outside. Now cosine square. Remember, if we have the power of it's odd, then this is going to be the order function. Here is even. We have to use the power reducing. Cosine square here is going to be 1 plus cosine of 2 theta over 2 d theta. Right, and then the 36 and the 2 cancel out. That will becomes 18. The integral of 1 plus cosine of 2 theta give us 18. Integral of 1 is easy, so that's just theta. And then integral of cosine 2 theta is 1/2 sine of 2 theta plus c. Right, multiply it out. 18 theta plus 1/2 times 18 is 9 sine of 2 theta. I don't know why I write the d theta here. So sine of 2 theta, that's not what we want. So we're trying to get around that. Sine of 2 theta, if we use the double angle, it's going to be 2 sine and a cosine. So that will be sine of 2 theta here. So that gives us 18 theta plus 9 times 2 sine and cosine. So that will be 18 theta plus 18 sine and cosine and the constant c. Alright, so all we know is x equal to 6 sine theta. So there will be a lot of work after this. Right, first, if x is equal to sine 6 sine theta, so we can say sine of theta is equal to x over 6, and so theta is equal to sine inverse of x over 6. So that will give us the sine inverse of x over 6. Next, we need the sine and the cosine. Since the sine is equal to opposite over hypotenuse, we will construct a triangle. angle theta opposite hypotenuse. Therefore, the equation is 36 6 squared minus x squared. So 36 minus x squared. And then we can find out sine is that, so cosine is going to be equation over hypotenuse. And so we have the sine here. It's just x over 6. And the cosine is square of 36 minus x squared over 6. And put everything together, we will have 18 times the sine inverse of x over 6 plus 18, 6 times 6, that's 36 at the bottom, cancel with 18, so that is 1/2 x square root of 36 minus x squared. So here, like, we have the 18 times that. Yeah, so no, that doesn't work. Yeah, that better. So the theta is sine inverse, the sine is this, the cosine is that. So if we put all together, that's what we have. 18 and 36 cancel out, give us 1/2. That's what we have. Right. Next, the integral that involves a squared plus x squared. That would be this one. 12. Right. We have the limit. Worry about that later. But if we have 1 square plus 1 square, right? Of course, that's what we use. Is going to be this one. We have to do something else before we go into the problem. What we say is that we have to turn this into 1. Remember, it's the constant square minus x square, or in this case t square. So this in front of coefficient, the coefficient in front of t square has to be 1. So we have to take care of that first before we do anything else. So what I do is, what if we multiply 1 over 25 on the top, and 1 over 25 at the bottom. Right, there will be a fraction and it might be a mess, but then we have to do that. So the top is 1 over 25, 1 over 25 plus t squared dt. Right. Multiply that inside. Alright, now it's ready. 1 over 25 is 1 over 5 square. Of course, we haven't multiplied this yet. 5 and 1 over 25, that is just 1 over 5 on the top. Sorry. Right. 1 over 5 on the top. Okay. Now the substitution. It's going to be a tangent. A is going to be square root of this. So let A equal to 1/5 tangent of t. Cannot be t, so theta, d theta. Derivative, let t be equal to a tangent, and a is 1/5. So dt is equal to 1/5 secant square d theta. Alright. So it will be 1 over 25 still, plus the t here is going to be 1/5 tangent square and dt is going to be this 1/5 secant square d theta. Alright. We still have the limit, which we'll deal with that later. Actually, this is not too bad of the problem. Okay. So it's just say 1/5, that 1/5 and that 1/5 actually are the same. So let's just say instead of 1/5 on the top, we multiply 1/5 next to it, and then we still have the 1/5 secant square. Yeah. So instead of put on the top, we can put on the side. Cannot put at the bottom, obviously. 1 over 5 squares. I forgot the square here, right? 1 over 5 square is 1 over 25, factor out. And then we have 1 plus tangent square. 1 plus tangent square is secant square. So actually this turn, it cancel everything. Turns out to be very nice, as that should be the tangent inverse. Anyway, okay, so we have 1 over 25. 1 plus tangent square is secant square. Secant square d theta. Sorry, kind of small here. Pronoun space there. Secant square and secant square cancel out. 1 over 25, 1 over 25 actually also cancel out, because divide by 1 over 25 is multiplied by 25, cancel with this. So pretty much everything cancel out, and we just have 1 d theta, which turn into a theta. Once again, we did not change the limit. We still have that. Right. Now if t is equal to, I don't know why, sorry, there's no d theta from the beginning. That's all we have, t equal to 1/5 tangent. So the tangent is equal to 5t, and the theta equal to the tangent inverse of 5t. Sorry, there's no d theta there. So theta is tangent inverse of 5t, where t equal to -1 to 1. So if we put 1 in, we have tangent inverse of tangent inverse of 5 minus tangent inverse of -5. We can just leave the answer like that. By the way, tangent inverse is an odd function which turn into another negative tangent of 5. So if we can write give us 2 tangent of 5. We can check real quick. Here I have a calculator. All I do, we just need to graph the tangent inverse. As you see, it is symmetric to the origin. So this is an odd function. Therefore, tangent of a negative is the negative of the tangent. So that is the tangent inverse. Right. That is the substitution of something square plus a variable square. Next, 10 and 11. I think I only need to do one. I'm going to go with 11. Right, so one more time. 11. We have x squared minus something square, so that would be this one. So it's going to be a secant theta. A is 6, so let x be equal to 6 secant of theta. Right, dx is equal to 6 secant tangent. We might need to determine the rest later, so just for now. We have x squared here. X is 6 secant. And then at the bottom we have again 6 secant. Let's square that. Should not draw like that. Times dt. dt is this, so it'll be 6 secant tangent. Yeah. So dx. Again, there's no x here. There's just t. Right. Let's simplify here a little. On the top we will have 36 secant square At the bottom 36, and so we will factor out 36. I just group the whole thing here and do that. We have 36 secant square minus 36. If we factor out 36, we have secant square minus 1, which is tangent square. So that will be 36 tangent square. Because I'm afraid there might not enough space here. Don't forget that is the 5/2. There's a 6 here too, right? Right. Now let's put on the top. On the top, what we have is 36 secant square and 6. 36 times 6 is 216 secant cube tangent. At the bottom, 36 to the 5/2. I just do that quickly on the calculator. 36 to 36 to the power of 5/2 is that. Seven, 6, and the second to the 5/2, 2 and 2 cancel out. We have tangent to the 5th. Let's see what we can simplify here. 216 divided by that, what do we have? 216 divided by 7776. Do we have fraction? 1 over 36. So that constant, those number together, bringing out size 1 over 36. A tangent cancel with this. We have the tangent to the 4th. Sorry, should put the calculator away. That gives us 1 over 36. Tangent and tangent to the 5th cancel out. So that is tangent to the 4th at the bottom. And then secant on the top. Alright, secant cube divided by tangent to the 4th. If it is multiplying, that's different story. So secant is 1 over cosine, and tangent is 1 over sine over cosine. So let's try that. 1 over 36. We might run out of space here. The secant cube is going to be 1 over cosine theta. Since that's a cube, this is also a cube. The tangent to the 4th. Tangent is sine over cosine. So since it divides sine over cosine, it's going to be flipped. Cosine to the 4th. Over sine to the 4th. Tangent is sine over cosine, so reciprocal divided by fraction is multiplied reciprocal. Cosine with sine, that cancel out. We should have 1 over 36 cosine to the 4th cancel out. We just have cosine, but I'm going to write actually just keep cosine on the top and sine at the bottom to the 4th power. Right, that's actually just a substitution. Actually, I'm going to write that substitution over here. If we let u equal to sine, then we have du here. So u equal to sine. So du is equal to cosine theta d theta. So we have cosine theta d theta here. So that's going to be just du. So 1 over 36. Right. Integral sine is going to be u. I don't know where it's going, but see what happened. That's going to be du. To the 4th power, that is. Now, that is going to be u to the negative 4. So 1 over 36. U to the negative 3 over negative 3 plus c. Right, I ran out of space here, so I have to continue on the other piece of paper. Right. Here. 3 and 36, that is 108. Right, and then u to the negative 3, which we can write that at the bottom. (108) u cubed plus c, and u is u is sine theta, but there's cube. Right. All we need to know is find out is what is sine of theta. Right. We know that t is equal to secant, 6 secant. So secant is t over 6. So when we have a right triangle of angle theta, secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Hypotenuse is t, adjacent is 6, so this is going to be t squared minus 6 squared. That's rather confusing. I think the problem has a typo, so either all of them is x, all of them is t. So here what we did say was it is x. So let's keep everything x then. So x and x. So let the typo from the original prompt. So this is x squared instead of t squared. Right. Now the sine is going to be opposite over hypotenuse. So negative 1 over 108 opposite. Just write out sine of theta, therefore is equal to opposite over hypotenuse. 6 squared is 36, of course. It's x squared minus 36 over x to the 3 half. To the 3 plus c. Multiply reciprocal. Since this is dividing, we want to flip that. Negative 108. Right. So we have the square root cube and then over x cube at the bottom. So we're going to write x cube on the top here, and then x squared minus 36. So cube on the top, cube the bottom, we flip it. So x cube on the top and that one at the bottom, also cube, then plus c. So we're going to leave the answer in that form. Right. Next we go to the partial fraction. Right, partial fraction. In that case, we have to write the integral as a smaller fraction. Right, first we're going to try to split. For partial fraction, there's two integral that is useful. So we refer to that if we have to. Right, so first, if we're going to split the 2x plus 32 x squared plus ax plus 7, we try to factor x squared plus ax plus 7, x squared plus ax plus 7, it's going to be 1 and 7. Well, we multiply it out, it should be that. So we're going to have an x plus 1 at the bottom and x plus 7 at the bottom. On the top we don't know what it is, so make it an a and a b. Degree on top must be less than the bottom. Since the degree on bottom is 1, the top must be a constant, so just a. Right, here if we multiply top and bottom by the least common denominator of x plus 1, x plus 7. So if we multiply everything on both sides, multiply both sides by x plus 1, x plus 7. The left hand side we just have 2x plus 32. If we multiply this two, x plus 1 cancel out, we have 8 and x plus 7, and then b x plus 1. Multiply it out, ax plus 7x, bx plus b, combine like terms, a plus b times x. This will be 7a, a plus b times x, and then 7a plus b. then we're just matching the terms. The 2x here must be the same as that. Because of it, a plus b is equal to 2. Next we have 32 must be equal to this. So I use the calculator to solve this system of equation. Let's put that here. Right. It's going to be second that key x to -1, and then go to math, go to option RREF, and I will hit alpha, zoom to go to the matrix, 2 rows and 3 columns. So we have two rows there, that's good, but the column has 3 columns, and click OK here. So 1 and 1 and 2 and 7. Notice, do not hit the enter key, use the arrow. So go to the next one, 1 and 32. Five and -3. B is -3. So the 2x plus 32, x squared plus ax plus 7 is 5 over x plus 1 -3 over x plus 7. Now we integrate. Now go back to the integral. To x plus 32, x squared plus ax plus 7. We're going to have this. And then this instead. This is a lot easier to integrate. And we use the formulas over there. We just say it's going to be 5 times 1 over x plus 1 minus 3 times 1 over x plus 7. Dx. So it would be 5 ln of course the formula is over there. Minus 3 ln of x plus 7 plus c. On the test, it is perfectly to stop at this stage. We can bring in the 5 and bring down in the 3. Like I said, this is perfectly fine to start at this step. But we can say ln of x plus 1 to the 5th minus ln of x plus 7 to the 3rd. And when we subtract the log, we actually can divide them. We have x plus 1 to the 5th and divide by the absolute values at the bottom, x plus 7. Yeah, we can just leave the answer in that form. Right, so the properties that we use is if we have the log of something and there's a coefficient in front of it, can take it inside. And if we have ln of m minus ln of n, we have ln of m over n, and that is exactly what we have to combine those two logs. Right, it starts to rain, so I stop the video here real quick to save the video, and I'll continue in the another video. When I upload, I will combine those two videos together, so you don't notice anything different. We continue on number 14. Right. Number 14. First, we try to decompose this partial fraction. Ax plus 36 x cubed plus 6x squared plus 9x. Ax plus 36 on the top. The bottom, we can all of them have x, so I factor out that x, and then 6x plus 9. X squared plus 6x plus 9, that actually x plus 3 squared. Right, now what we see is the decompose of the form. We have the x and the repeated x plus 3. So we have the x, and for the x plus 3 repeated, we're going to have the x plus 3 and the x plus 3 squared. If that is the cube, we're going to have the cube also. But that is how we deal with the repeated factor. On the top, this is just going to be a. The power on top has to be less than the bottom. So this is not a b. Even though this is a quadratic x squared, but the top is going to be the same form, the same degree as that. So we just have c like that. Now what we do now is we multiply top and bottom by the least common denominator, x plus 3 x times x plus 3 squared. So multiply all of that by x times x plus 3 squared, x plus 3 squared. Right, cancel that out. We have ax plus 36. X and x cancel out. A x plus 3 squared, and then b x plus 3 cancel out, and then x plus 3 squared cancel. We have cx. Right, multiply it out. X plus 3 squared is x squared plus 6x plus 9. This is bx squared plus 3bx, and then cx. Ax squared plus 6ax plus 9a plus bx squared plus 3bx plus cx. Combine like terms. Square here, bx squared here, so that a plus b times x squared. Now the ax, 6ax, 3bx, and cx. So we have 6a, a 3b, and a c. And then just 9a. and then we will match the power. There's no x squared here, so that's just a plus b. The 6a plus 3b plus c will be equal to ax. So that will be 6a plus 3b plus c equal to a, and then the 36 is 9a. I'm going to solve this system of equation using a calculator. Let's put that here. Let's do this real quick. Right. So second matrix, go to math and go down to RREF, hit enter, and then to get the matrix alpha, zoom, this one, there are 3 equations, so there will be 3 rows and 3 variable and a constant, so that will be 4 columns. Okay, so 1 for A, 1 for B, there's no C, the constant 0. That's what happened when we hit the enter key. So have to hit this for the values. Again, second matrix, alpha, zoom, 3 row, 4 columns, so that's good. Right, do not hit enter this time, just hit 1 and then hit that next key. Yeah, use this next instead of the enter. If you hit enter, you get out of this. So 1 for B, 0 for C, and 0 for constant. 6A, 3B, 1C, and 8. (9A), no B, no C, and 36. Right, 4, -4, and -4. Right, so if we put this back into this form, it is going to be 4 over x, -4 over x plus 3, and -4 over x plus 3 squared. Right, so that integral from the beginning becomes 4 over x. I need to put the calculator away. Alright, so since a is equal to 4, b is -4, and c -4, this is the partial fraction. Then we're going to put that in the integral. Right, and then we split the integral. We should have 4 1 over x, that one easy, and then 4 1 over x plus 3, and then 4 1 over x plus 3 square. Right, The first one gives us ln of x, ln of absolute values of x. The next one is ln absolute values of x plus 3. And this we just use a little substitution. If we let u equal to x plus 3, du is going to be, derivative is going to be 1. So du equal to dx. So we will have 1 over u square du, which is dx. So we have 4 ln of x minus 4 ln of x plus 3. Integral is going to be u to negative 1 over negative 1 plus c. Right. So for ln of absolute values of x, minus 4 ln of x plus 3, that can be 4, and u to negative 1. So let's just put that at the bottom, 1 over u, and u is x plus 3 plus c. So it's perfectly to start to get the answer in that form. So that was 14. We can combine these two logs using these properties, but the point here is just do the partial fraction and integrate the rest. It's not really as important. Right, this one. We're going to decompose the x squared, x cubed plus 9x. So, I mean the whole fraction. The top is still there, 6x squared plus x plus 45, but the bottom, both of them have x, so let's just factor it out. X squared plus 9, we cannot really do anything with it, so just it is irreducible, so that's all we have. So we're going to have the x at the bottom and x squared plus 9 at the bottom. The top has to have degree less than the bottom. So if degree here is 1, the top can only have a constant. If degree is 2, the top can be just the first degree polynomial. What we do now is we will multiply both sides by the denominator of x squared plus 9. Multiply this onto both sides. This gives us 6x squared plus x plus 45, and then x and x cancel out. Here we have a and x squared plus 9 and bx plus c. X squared plus 9 cancel, there's just an x left. Multiply it out, ax squared plus 9a, and then bx squared plus cx. Combine like terms for the square, a plus b and then the cx that we have for the first power, and then the second power because it's just 9a, so that term. On the right hand side we have 6x squared and x and 45. I'm trying to write the same color, the same terms, the same degrees, so then we can match 6x squared with this. Give us a plus b equal to 6. C is going to be 1, and 9a equal to 45. So this is simple enough. We don't need the calculator to solve this equation, because we already know that a is going to be 45 divided by 9, which is 5. C is going to be equal to 1, and if a is 5 plus b is 6, so b is -1. I should decompose that. Should a partial fraction, we take the form of this form. A is 5 over x plus b is -1, and c is 1, x squared plus 9. Yeah, so it will take this form, will turn out to be 5 over x minus x plus 1 over x squared plus 9. Right. So that integral, by the way, this will take a lot more space than I expected. So we have 5 over x plus minus x plus 1 over x squared plus 9. Well, we have 5 over x. That's very easy to do. But for the other, we're going to split as follows: minus x over x squared plus 9 minus, and then 1 over x squared plus 9. The reason we split like this, because that gives us the tangent inverse, the formula over there. Talking about this one, 1 over x squared plus 9, that is. Again, run out of space here. So we'll continue on this piece of paper. Right, I will split that integral. 5 over x dx minus x over x squared plus 9 dx, and then 1 over x squared plus 9 dx. Right, the first and the last is easy. That gives us 5 ln of absolute values of x. That should be easy. This gives us 1 over 3 tangent inverse of x over 3. If we apply that formula where a is equal to 3, we have x squared plus 9, which is x squared plus 3 squared, so a is 3. I just don't know, don't have to see yet. I just don't know how to do that yet. For that, we use the substitution: u equal to x squared plus 9. Let u equal to x squared plus 9. Derivative is 2x, so du is 2x dx, or we can say du over 2x is dx. X over x squared plus 9 is u, du dx is du over 2x. X and x cancel out, so we will have 5 ln of x minus cancel out x, the 2 here, bring it outside, the 2 at the bottom, 1 over u du plus 1 over 3 tangent inverse x over 3 plus c. Still don't have c yet, we still have the integral. So give us 5 ln of x minus 1/2 ln of absolute values of u, and u is x squared plus 9. Yeah, 1 over u is ln integral 1 over u is ln of u, and u is x squared plus 9, so that's what we have. By the way, if we can also write x squared plus 9 as a parentheses, because absolute values of x squared plus 9 is already positive, so the absolute value is kind of redundant. Right, so we are going to keep it like that. Alright, let's see, let's check again. So from the beginning, we do the partial fraction, and all of that, just notice that this have to be positive. So that is actually positive. Right, so positive. Again, so the integral, even better, all positive. Right, so partial fraction, we have the coefficient, we solve for it, take this form, and that's what we have, and then we want to put back into the integral. We have x plus 1 here, we have to split, because the 1 over x squared plus 9 is the tangent inverse. This one is going to be a substitution, and in fact we do the substitution, and this is what we have. And once again, I apologize, that should be a plus, all of this should be a plus. So that's what we have. I zoom out. Right, numerical integration. So for this one, we just want to sketch that real quick. It doesn't have to be positive or negative. The function is negative, by the way. So just say the function is, say, we actually can graph it. So if we have y equal 2 and look at the graph, something like that, like that, not really matter. Alright, what matters here is the interval that go from -1 to 1, and we divide that into 4 equal pieces. And after that we'll take the midpoint. Those midpoint give us the height, and we're going to draw the rectangle based on that height. The height. So the height based on the midpoint. So the midpoint here is negative 0.75, negative 0.25, 0.25, and 0.75. And so we have the width is, since we go from -1 to 1, the length is 2 divided by 4, so the width is 1 minus negative 1 divided by 4. So going to be 2 over 4, so 0.5. So the width is that. Now the integral, in which case is approximately equal to, we have the values, the function values at those points. So length times width. So the length on the length is the values of the function 7.5, negative 2.5, 0.25, and 0.75, all of which we will multiply by the width, because in the formula that is the dx, delta x, which is the width. Right, I'm going to use a calculator on this one. Right, calculator. You see above the parentheses, you see that on the calculator, above the parentheses we have the curly bracket, and then we're going to use this button. Above 1, 2, 3, 4, 5, 6, you see the L1, L2, that is the list, which we're going to use that also. So second parentheses, and we're going to enter the numbers, negative 0.75, hit a comma, negative 0.25, comma, 0.25, comma, 0.75, close the curly bracket, store into the list one. We did enter the function y equal to, if we didn't do that, negative 3 e to the, let's do that again, negative 3 second ln and then 3x. Right, second more quick. Now, so that function is y1. So if you want to recall the y1, we hit alpha, trace, and y1. If we want to evaluate, put in the x values, that is when x equal to 1, that is the values of the function. We want the values of all of those functions, or those values. So we're going to hit alpha, trace, y1, hit L, and then we're going to hit second L1. So all of those numbers, right? All of this, we're going to just add them up, and at the end multiply by 0.5. So if we do second stat, go to math, option number 5, that is the sum. Add go up. Let's add all of them up. So we're going to add all the y values at those points, and we multiply by 0.5 the width. So that is negative 18.274. So that is the midpoint rule. Again, we have the values of the function at the list. We can add all of them up manually as well. So second stat, option number 5, and then we just add what we have earlier, and then just multiply 0.5 to it. Yeah, so that's what we have. So that is the midpoint rule. Right, next, the trapezoid rule. Always first find out what is the width. So the width here, which is the delta x, Let me update the list first. The midpoint rule, that was number 17. The trapezoid is 18 and 19. The width is going to be 2. The length is go from 0 to 2, so that's going to be 2, but we're going to divide into 4 pieces, so 0.5 each. So that is dx. Right, the trapezoid rule, the formula is over there. So let's just say we're going to have from 0 to 2, divide this into 4 equal segments, so it has to be at 0.5, 1, and 1.5. We're going to need the function values at those points. And the midpoint rule focus on this part. You see, the first point is 1, and everything in the middle is going to be 2. So the coefficient is 1, 2, 2, 2. Everything in the middle is 2, 1 at the end. So first we want to put the function ax squared we'll put ax squared into a1, I mean y1. Hit enter. That's good. Now second mode to quick, we're going to enter this values function. I will bring the calculator back here. Actually, that works. Right. The list of numbers 0, 0.5, 1, and 2. Store that into list 1. Did we miss something? 1, 1.5, and 2. Store into list 1. Right, so that is L1. Right. Now we will evaluate the function. Add the list. Right. If we're going to write out, we're going to have the values of the function at 0, the values of the function at 0.5, the values of the function at 1, at 1.5, at 2. We cannot just add it like that. The coefficient have to be 1 of this, 2 of every one in the middle, and 1 at the end. After, sorry to put the calculator on the way. Yeah, so I have the values of those functions, and then the coefficient 1, 2, everything in the middle is 2, the outside is 1, and after that we still have the 0.5 divided by 2, which is the delta x divided by 2 in the formula. Yeah. So if we put in a calculator, we put those numbers onto list 1 and then evaluate. We do that, put the number into list 1 and then alpha trace y1. I'm going to put second one, so we have the values inside. All we need to do is multiply by the coefficient. We can do that also. Let's say second parentheses and 1, 2, 2, 2, and 1. All we need to do is multiply by the corresponding numbers on the top. So just go here, hit enter. Not copy and paste. So we copy all those values here. Right. And then we just add all of them up. Second, stat. And if we just want the last answer, so hit second answer. And that's what we have. So we know inside is 88. And then we still have to multiply by 0.5. Sorry, to calculate on the way again. Inside we have 88, and then multiply by 0.5 divided by 2, so that is 22. So pretty much the same way as we have. Just we're going to store this into L2, and to get the values of the function we have y1 of L1, so that gives us all the values of the function, and then we multiply the L2 to it, give us everything in the parentheses. Right. I'm going to skip 19. And the Simpson rule, kind of same way, but the Simpson rule is that on that side. Right, so n equal to 4, go from 0 to 2. So first the width, delta x equal to 2 minus 0 divided by 2 by 4 pieces. So that's going to be 0.5. Right. So the width is 0.5. Right now we're going to divide the interval from 0 to 2. 4 equal pieces, so that's going to be 0.5, 1, 1.5. We're going to find the values of the function at those points. Right, but the coefficient in the Simpson rule is going to be 1, 4, 2, just pretty much 4, 2, 4, 2, 4, 2, 4, 2. And then we have 4 and then 1, so kind of symmetric of the 1 and 4, and then there will be 2, and then 4, 2, 4, 2, 4, 2, 4, 2, and at the end it will be 4, 1, and so that is so pretty much we enter everything here already. So the list of number from 0 to 2 we already did that, so we I just write that first. So the approximation is going to be the values of the function at 0, the values of the function at 0.5, the values of the function at 1, and then so on. The coefficient 1 of the first one, 4, 2, 4, 2. When we stop, it have to be just 4 and 1 to stop. And then don't forget that delta x divided by 3, the width divided by 3. Alright, so inside the parentheses, I'm going to use the calculator. I'm going to put the calculator over here. So first we enter the numbers onto L1, so we did that already. Right. and then enter the function, which is happen to be the same as number 18, so don't do anything there. And then just on the home screen, hit alpha trace y1, and we evaluate at L1. So we have the values of the function at this point, but we're not going to take those values. We have to have the constant 1, 4, 2, 4, 1. So we're going to enter 1, 4, 2, 4, 1 onto list 2, and then we're going to take list 1, list 2 times whatever this is, whatever the values here. We can enter them manually, or we just say go up, hit enter, copy and paste the values of 0, 2, 8, 18 and 32. Alright, and then we're going to add all of this up. Second stat, we're going to add all of this up. Either you do that, or you go up here, copy and paste, hit enter, it becomes copy and paste. Right, so we have 128 inside, and so we have 128 times 0.5 divided by 3, 0.5 times 128, 64 over 3. So that's what we have. So that is the Simpson rule. Right. Next, we go to improper integrals. Improper integral, we do two things. First, it due to we have the infinity at the limit, or it is undefined as somewhere in the middle. Infinite limit we have from 21 to 25, 24, and unbounded integral, that is 25. 21 to 23, 24. I think I'm going to do 24 in class. So let's focus on 21 and 23 here. Right. See so far. Here we have 21. Actually, I'm just do 21 and 23. 22 we go just quickly through it. Right. First, the infinity here make the integral improper. So do that. First thing we have is take care of that, and we say let a or any number or any letter goes to negative infinity. And then we can say it go from a to 0. And then the rest is easy. We just do the integral, and then at the end we put the limit to it. Right. So the integral, I'm going to use the substitution here. Let u be x minus 1. So in that case, du is going to be 1 dx, so that's just dx. And then we have the chain of the limit. When x equal to a, u is a minus 1. When x equal to 0, u is 0 minus 1, negative 1. So that integral becomes a minus 1, 2 minus 1, 17, x minus 1 becomes a u square, dx is du. So we have limit a to negative infinity, a minus 1 minus 1, 17 u to negative 2 du. Integral of that is u to the negative 1 over negative 1. Evaluate from a minus 1 to minus 1. So which turn into negative 17 1 over u. Right, move this to the bottom, becomes u to the first. Evaluate from a minus 1 to 1. So we put 1 in it, we have negative 17 over 1, negative 1, sorry. So that is going to be u. Let's just say yeah, that's better. So negative 17, we put negative 1 in it. I forgot the limit, did I? And then minus negative 17 over a minus 1. Right, too many negative, let's just simplify. That is 17 over a minus 1. Now, as a goes to negative infinity, this goes to negative infinity. 17 over infinity is going to be 0. So that one will go to 0. Because we have a finite amount divided by infinity at the bottom. That's going to go to 0. And so we just have 17. So be just that. Next, again, whenever we have the infinity at the limit, that is improper, and to make it proper, we have to put the limit. Usually the upper limit we use b, the lower limit we use a. Turn that to a b. I'm going to write 2 over 36 plus x squared. Put the dx on the side. Right. Let's see what we can use here. We do have the integral of 1 over x squared plus a squared. This one a squared plus x squared. The same difference. But anyway, so limit of b goes to infinity. Let's put the 2 outside. And I put x squared plus 36. So that's exactly like the form we have in that formula. So that gives us limit of b goes to infinity. 2 times 1 over 6 tangent inverse of x over 6, and all of that go to 0 to b. So we have limit of b goes to infinity. 2 over 6 is 1/3. Tangent inverse of x over sorry, we haven't again. Yeah, so we write like that, and then the integral will be just like the formula says, 1 over 6 tangent inverse of x over 6, and I'm going to put b in it, I'm going to put 6 in it. So we have b over 6 minus 1/3 tangent inverse of 0 over 6, so just 0. Right, use the help of the calculator here. First, let's see the tangent inverse. Second, tangent inverse. It doesn't matter in degree or radian. Just see the graph. It looks like that. Now, actually, it's in radian. It doesn't matter though. We need the tangent inverse of a very big number. Since b go to infinity, that is the tangent inverse of a very big number. So we just do that tangent inverse of that. I think that's big enough. And this is close to actually pi over 2. So this is 1/3 of pi over 2. Because tangent inverse is approaching to pi over 2 when x go to infinity, and tangent of inverse of 0 is going to be 0. So that minus 0, it is 6 pi over, pi over 6. Yeah. So just, yeah, pi over 6. Right. Next we have the improper integral as well. The problem is here. Right, so to make it proper, we're going to introduce this in the integral. Go from 0 to b, ax and e to the 2x dx. Now that integral requires integration by parts. So integration by parts, I'm going to use the little table here. This to be differentiate, integrated, ax, e to the 2x. Ax is 8, derivative 0. Integral is 1/2 e to the 2x, or 1/4 e to the 2x. So we have limit b goes to infinity. That a plus, that a minus. So we're going to have ax times 1/2 e to the 2x minus 8 times 1/4 e to the 2x. The values go from 0 to b. That gives us 4x e to the 2x minus 2 e to the 2x, 0 to b. Now 4x, so they're going to be 4. We're going to put b in it. 4b e to the 2b minus 2 e to the 2b minus 4 times 0 e to the 2 times 0 minus 2 e to the 0. Right. Now what we have here is, since b go to infinity, this is going to be, this go to infinity. In fact, if we factor it out, I think we should do that. So it is easier to see. If we factor it out, e to the 2b, we're going to have 4b minus 2. And this is 4 times 0, so this is 0 minus, so that's plus 2. This, because of 0 equal to 0, e to 0 power is 1, so minus a negative 2, so that's plus 2. Right. Notice b goes to infinity, so we have infinity here times also infinity. So we have infinity times infinity, of course, even. It's still infinity, by the way. So infinity times infinity plus 2, still infinity. So this one is equal to infinity. So that's why we write that divergent, because the limit does not exist. Right. Of course, if we draw the function that ax, so it's going to go to infinity very fast, and the area therefore goes to infinity as well. Right. So that the improper integral with the improper limit, I'm sorry, with the infinite limit. Now we go to the unbound integral. We're going to should be able to, we should do that in class. Right here, of course, when we look at this, there's nothing wrong with the function, but with the limit there's something wrong, because from negative 1 to 27, when x equal to 0 at the middle, it is undefined. So if we go from negative 1 to 27, it is undefined at 0. So for that we have to split at 0. So this problem becomes negative 1 to 0 of 1 over x to the 2/3. Again, I always want to write the dx on the side. And then from 0 to 27, 1 over x to the 2/3 dx. Right. Remember, it's undefined or unbounded at 0, so here we have to do. So actually there is a problem with this. So we're going to write limit when x go to 0. Notice from negative 1 to 0, it go to 0, but from the left side, x to the negative 2/3 dx go from 0. Let's not use x here, that would be upper limit, so let's use b instead. Next, x0 is undefined too, so we say a go to 0, but from 27 it's going to go to 0 to that side, so it's going to be a plus sign. The low limit we use a, so that's going to be a here, 27. Right. So because 0 is undefined, we have to split right 0. Right. Now we just need to do this. It's not too bad. The integral is just x to the 1/3 to 1/3. Need to evaluate from 0 to b, and similarly here, x to the 1/3 to 1/3 that go from 8 to 27. Right. So divide by 1 over 3 is multiplied by 3. Sorry, this one from -1. I don't know why I do that. Right, so limit of b goes to 0 from the left hand side. Three b to the 1/3 minus 3 times -1 to the 1/3 plus limit when a go to 0 plus 3 times 27 to the 1/3 minus 3 times a to the 1/3. Right, b go to 0, 0 to 1/3, so that one 0, and we can say a go to 0 as well, so that one go to 0. All we need to have this -1 to the 1/3. The 1/3 power is the cube root. So the cube root of -1 is -1. We can use the calculator for that. Just say -1 to the 1/3 is -1 times 3. So that's going to be equal to +3. And then the other one, 3 times 27 to the 1/3. Cube root of 27 is 3. 3 times 3 is 9. So we're going to have 12. That's what we have. So when we have the function that is undefined at a point in the middle, we have to split at that point. Right. Next we have the separable equation, differential equation, separable equation. And the linear first order equation. I think I forgot to put the separable equation here, but in any event, this kind of equation is going to be both. I'm going to do both on 26. Right. Differential equation. So first, if we're going to use the linear equation, so this is in the standard form, and we have p of x, in this case is 2. So first we're going to do the integrating factor. Integrating factor is e to the integral px dx. So we have e to the integral of 2 dx give us e to the 2x. And we write the problem again, but this time we multiply e to the 2x on both sides. Multiply this, the integrating factor on both sides. Right. So when we multiply it outside, don't worry about it. On the left hand side, all we have is just the integrating factor, and then the function. I may have to save the video again, otherwise it might lose the power. Anyway, so we just have derivative on the left hand side. If you wonder why is that, because this is a product rule. What it actually is, here we have u v prime, sorry, that including the 2 here, u prime and v. So that is the product rule where we have u and v inside. That equal to 25 e to the 2x. All we do is just integrate both sides. Integrate both sides, we get out of the derivative. Again, I forgot this had to be t. So e to the t, sorry, t, not x. So 2t. This to the t, t, and t. And then integral of 25 e to the 2t, which is simple. Left hand side e to the 2t times y. Integral of that will be 25 times 1/2 e to the 2t plus c. So e to the 2t, 25 over 2, e to the 2t plus c. Divide e to the 2t on both sides. We have 25 over 2 plus c. Bring this up, we have that. Initial value problem. This pretty much we do the same way. I think we want to do 27 here. Actually, we don't have any separation of separable equation, so we're going to do that in class as well. So we don't have anything in this review. Sorry, forgot to put that here. But anyway, we have 26, and we're going to do 26 and 27. 28 will be similar. Right. 27. Move everything on one side here, because it has to be in the standard form. Move the 4y to the other side. So the form for the standard form is the derivative, something, the function, and then anything else. We do not have any y on that side. Alright. So this is in the standard form already. The p of x is going to be -4. So now we do the integrating factor. Mu equal to e to the integral px dx. Which equal to e to the integral of -4d. I just keep doing that. Again, this variable t for dt, so e to the -4t. Right. Multiply this on both sides of the function. So we're going to multiply e to the negative 4t regardless of what on the left. This is always just that integrating factor and then y. Integrating factor and y is always just that. It's the product rule, so still derivative. Then integrate both sides. The antiderivative undo the derivative. So we have e to negative 4t times y equal to 20. Integral of that is 1 over negative 4 e to negative 4t plus a constant c. So we have e to the negative 4t times y equal to negative 5 e to negative 4t plus c. If we multiply both sides by e to the negative 4 or divide by e to the negative 4t, either way. So y equal to negative 5 plus, and I move that on the top, e to the 4t. Oh, did I forget anything? Right. The left hand side is negative 20. The negative 20 is still on the right hand side, so that should be negative still. Negative, 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 negative. And because of that, turn to positive. So that is the general solution. Right. Next we have the initial condition of y equal to 0 equal to 9. Meaning when x equal to 0, y equal to 9. Of course, t equal to 0, y equal to 9, so y is 9. E to 4 times 0 plus 5. E to 0 power is 1. So since we have here 9 equal to c plus 5, so c is equal to 4. And put it back into the equation, we have y equal to, since c is equal to 4, we have 4 e to the 4t plus 5. Right. The next problem, we do the same thing. We just need to move the 5u on that side equal to 15, and then we just keep going with and do the same thing as we did before. Right. So here we only have the linear first order equation. The separable equation, we're going to review that in class. It will not be that complicated. But at any event, we cover all the topics that is in this test review. The separable equation and some other questions that we haven't covered yet. We're going to do that in class. And we finish this, which means we finish everything. I hope you find this video helpful. It's a little bit long, but I think this is a good review for the test. Thank you for watching.